The question says, the pH of a 0.225 molar weak acid solution HA is 4.05. What is the Ka of the acid? So if we write the Ka expression, as we did in the previous problem, Ka is equal to the concentration of the products, H3O plus, in this case times A minus, over the concentration of HA, like so. So in this case, we're given the concentration of HA, the initial concentration of it, all right, and we're also given the pH, and then we're asked for the Ka of the acid. So in this case, we're actually able to find the change in concentration. So if you haven't watched the previous question, it's a good idea to do that. And how can we do that? Well, we could find the concentration of H3O plus by taking 10 to the negative pH, which in this case is 10 to the negative 4.05, which will give us a concentration of H3O plus, which is equal to 8.9 times 10 to the minus 5 molar. So now we can plug in the ice table. The initial concentration of the HA is 0.0 or 0.225 molar. The molar is up here. The initial concentration of H3O plus and A minus is both 0. In this case, we're going to add 8.9 times 10 to the minus 5 molar H3O plus. How do we know? Because we measured the pH at equilibrium and we found that it was 8.9 times 10 to the minus 5. We also know that the concentration of A minus has to be the same because for every one of these that reacts with water, you get one of these and one of these. So we must have also gained 8.9 times 10 to the minus 5 of the A minus. Now, here is where, things are kind of in between. We're going to subtract 8.9 times 10 to the minus 5. You'll notice that this is 4 orders of magnitude smaller than this. So do you really need to subtract it? Probably not. So we're going to just assume that this is negligible and that equilibrium, this is 0.225. This one is 8.9 times 10 to the minus 5, and this one is 8.9 times 10 to the minus 5. What this is basically telling us is how we could calculate the Ka of an acid. If we know the concentration of the weak acid and we know the pH of the solution, we could find the experimental Ka of the acid. So here we could find the Ka is equal to 8.9 times 10 to the minus 5 times 8.9 times 10 to the minus 5, because these are both that, divided by the concentration of HA, which is 0.225. And when you do that math, you find that the Ka is 3.5 times 10 to the minus 8th. All right, so this is the Ka of this particular weak acid.